Hi guys, this is Vishal here, and I'm Rahul. And here we're presenting our favorite series of NLTK, which is the Python library. Here we go.
Hi, I'm Rahul Singh, and in this tutorial we'll be learning about Natural Language Toolkit and how to use it to perform various natural language processing functions. So first, I'll be giving an introduction about what exactly is NLP and what are its uses in modern day-to-day life, and then after that I'll be showing you how to install Python, and if you already have that then you can skip that step, and then I'll show you how to install NLTK, and then I'll show you some very basic examples of NLTK, and then there will be a video that will give a detailed example of how to build a sentiment analyzer using NLTK. So let's get started. Now, what is natural language processing? Natural language processing refers to understanding the context, the intent, and everything related to statements made by humans, and not not just statements, but it could be anything that is related to communication. So where is natural language processing used? Natural language processing is used in search engines, so that when people do queries, uh, better NLP algorithms can make a better sense out of them, and they can give exactly what the person who queried what he wanted. They can exact NLP is used in various areas, one of them being search engines, so that when you query something, you're trying to find something in your Google, then the search engine will be more equipped or better equipped to understand what you are trying to search for, and it will give you those queries, those results that you were looking for. It can also be used for banking fraud detection, so that it can detect any number of frauds which could be false statements by people, or any other type of misleading information that could be detected using NLP. It can also be used by spam filtering. As we can see, there is a lot of spam present on the internet, and spam filters like Google's spam filter, or spam filters belonging to any other popular messaging clients, do a pretty good job in filtering uh, the data that you want and the data which you probably don't need. It can also be used NLP can also be used to extend knowledge bases and expert systems. An example will be an AI like Siri or Cortana that learns uh, or from the data that it has been given from the user, or it trains itself to give the user a better experiences, better experience, so that the user may return again to the system. It can also be used NLP is also used in automated customer support systems, so that you don't need a person sitting on the other side of a phone on a customer service call. It can be an AI, and the AI can support the customer in every way that is possible, without there being a need to of a person sitting 24/7 and taking the calls of all the customers. And NLP can also be used for site recommendations, as it understands what the user wants and performs accordingly. So let's see the basic terminology of NLP. First, we have classification. So classification is the process of classifying different parts of the sentence, or different parts of a text, into various classes, and these classes and sorry, but this classification can be categorized into two um, categories, which is supervised and unsupervised. In unsupervised classification, we already have classes or result data set, and we know what our classes should look like, so we have something to train upon. We have example classes to train upon, and in unsupervised classification we don't have any example classes to or ideal data sets to train upon. Next we go to tagging. Tagging is the process of attaching part of speech, tense, related terms or other properties to tokens of text. And then we have tokenizing. Tokenizing is the process of breaking text into defined segments. Now, tokenizing can be used to tokenize words, punctuations, alphabets, or any other parts of speech. Now, stemming. Stemming is the process of breaking words into their stems and removing their plural forms. For example, walked. Now, you have to extract walk from walked, so it become you're taking the walk and removing the ed and walking, and now you have to extract walk and remove the ing. Now these things seem pretty simple to us humans, but they can be really challenging for a program. Collocations. Collocations are short sequences of words that commonly appear together. We'll elaborate more upon these as we go forward. Now, why are we using Python? Python is a great language for NLP simply because it's one of the simplest languages to learn, and it has a really good learning curve, and it's very easy to debug. There are a lot of exceptions that and which point out to what the problem in the program is, and Python also being an interpreted language is more common and easier to compile, not compile but easier to debug. Python is also very easy to structure because of the large number of modules and packages, and the structure of um, Python in general. Python is also following object-oriented programming principles just like Java and C++. And especially for advantages for NLP is that Python has a very powerful string manipulation process, so it can be used to very easily manipulate strings or any other form of data structure similar to that when compared to other languages. Now for the installation part, if you don't have Python, just go to python.org/downloads. So let's get started with the installation. Now just go to python.org/downloads. Sorry about that. Now go to the download section, and then this video I'm doing this video on Windows, so I'm going to the Windows section and I'll choose either 3.4.3 or 2.7.9. Now I'm choosing 2.7.9 here because it's a more stable release of Python, and there are still many libraries that only support 2.7.9, but you can also choose 3.4.3, and it also has some exclusive libraries, but it amounts to personal taste sometimes. Now I already have Python installed, so I'll just as I already have Python installed, I'll straight away go to the idle, which is the default Python GUI provided in Windows systems. Now, the second step is to install NLTK. To install NLTK, just go to nltk.org/downloads. nltk.org/downloads. Or you can download NLTK directly from the idle GUI. So go to the GUI and write import NLTK and NLTK dot download. Now it's showing all the packages that you can download. You can select either of them and just choose what you want to download. I'll just go with the all option here. I would highly recommend downloading these packages because they don't take a lot of space and they can be really helpful in understanding some functions, because some NLTK functions require a very large amount of data, so or a very specific format of data, so it's better to have them. Now while it's being downloaded, we can move to some basic examples of NLTK. Let's open a new Python idle GUI. Now let's move on to the very basics of NLTK. First, I'll show you example on part of speech tagging. So first, let's import the package which we will be using for this example. So write from NLTK import POS, that stands for part of speech, tag, and word tokenize function. Now when this is done, let's give it an example where we shall run our program. So now let's convert it using the tokenize function. So I'll just pass the sentence that we wrote above into the word tokenize function, and the output will be passed to the send-to variable. And as you don't need declaration in Python, we'll just write this here. Now when this is done, let's print it. Now as you can see, uh, send2 send2 contains the tokenized or the tokenized version of sentence. Now let's try out another example. In this example, I'll be using default text given in NLTK and a package named brown. So from NLTK dot corpus import brown, and from NLTK import the text. Now let's try something. Now I'll define a variable bw, and let's see what happens when I pass it a function called words, and I pass it a category of humor. And now let's pass this bw variable to another variable called brown text, which will convert this first into text. And now let's see what we can do with the brown text. First, let's try out the collocations that can be made on this piece of text. Looks like I made a mistake there. We don't need to pass the brown text as a parameter because we are calling collocations method on the brown text object, and as Python has every variable as an object, we don't need that. So as we call that, we can see the collocations made by the program. So you have Mr. Crombie or Mr. Blatz or Police Captain Mother Cabrini. So you can see that the program is very good, but not perfect, but very good at making assumptions about collocations. Now let's see another function called count, and as its name suggests, it counts the number of occurrences of a particular word in the given body of text. Okay, so the T is capital there. Oh, right, forgot calling the method there. So in Python you have to be very specific about the indentation, and also the word to be passed here should be in double quotes, not single. Now as you can see, it gave me a number which is the number of occurrences of the word car in the brown text. Now let's see the concordance of a specific word in the given text. Concordance means the relation or the context in which the word was present. as you can see, it gave us a word, it gave us a sentence of the text relating to the word that we passed there. Now let's see how many similar words are present to a particular word. Brown text dot similar. I'll pass humor here, and it give me some words like satire, outspoken, poetry. Yeah, it's, as you can see, it's not a perfect program, but it can give some very good results at at some specific data. Apart from these things, we can also use NLTK for many purposes, mainly relating to machine learning or scientific things, and it can also be used for some not so academic things. For example, in NLTK there is a package called ELIZA. So let's try that out from NLTK dot chat import ELIZA. Now ELIZA is a chatbot, so you can chat with it whenever and wherever you want. For example, if I write I am good, as it's a very basic response, it already has an example about that. But it has a lot of responses to different questions and queries that we can post, and these are all based on functions, on programs and modules based on NLTK. So there ends the first part of the tutorial series. In the next part of the tutorial series, we learn about an example of sentiment analyzer which is made by NLTK.
Hi guys, this is nobody in particular here. So here we have a tutorial for making a sentiment analyzer in Python, and to make this we're going to use NLTK. NLTK is a library that is based on Python. It's called Natural Language Toolkit, and it's basically used for natural language processing and any kind of program or application that has something to do with natural language processing is basically used NLTK. It's a pretty popular library, and you can check it out on nltk.org. So to begin with, there's a small slide where we're going to talk about what sentiment analyzer actually is and what it does. So what is a sentiment analyzer? It's also known as open-end mining. Now it uses natural language processing and text analysis to extract subjective information in source materials. This is straight out of Wikipedia. So we use natural language processing to extract information out of the text. Text could be a document, it could be a paragraph, it could be a small sentence, it could be a tweet out of Twitter. So our objective is to gather information out of these tweets, out of these information, out of these paragraphs, and based on what we want. So if say we want something in particular, like only good words or only happy words, then we can build a program that does that, and we could do it anything. We could make a program that does anything else as well. And basically, our aim is to determine the attitude of a speaker or a writer with respect to some topic or based on the overall context of the document. So, say we have a paragraph out of a novel. So, we're trying to understand the kind of tone that the author is talking about in this case. So based on the analysis that we perform on that paragraph, we'll be able to understand that the serial tone of the paragraph was harsh, or it was rude, or it was sarcastic, or whatever it was. And we'll be able to do that out of basically that is what natural language processing is all about. Now, how are we going to do this? We're using NLTK. It's a Python library used for natural language processing. So we have a number of tweets in our case that are manually entered, and they have been classified into two categories, either positive remarks or negative remarks. Now these tweets will be used as training data for the classifier, and we'll be using naive based classifier in this case. So we'll be training the classifier based on these tweets that have been manually entered, and once the classifier is trained, we'll be able to predict for future sentences that okay fine, this is a positive remark or this is a negative remark, and so forth. So let's jump into the code. So I've already installed NLTK using pip, as you can see here. I'm using Windows because that's a lot more comfortable for me. So let's just go through down the code. So we have two variables here. They are basically lists, pause underscore tweets and neg underscore tweets. Pause underscore tweets, as you can make out, holds the positive tweets. So there's I love this car. This view is amazing. I'm excited about the concert, and so on. And these have been classified as positive remarks. So this is our manually entered data that is positive. And then we have neg underscore tweets. I don't like this car. This view is horrible. I feel very tired. And these are negative remarks. So we have used these for our training data, and they have been manually classified initially before we do the further processing. Now here, what we're trying to do is we're trying to break down these sentences that have been given in these two lists, pause underscore tweets and neg underscore tweets, into words. Now by words I mean anything that has got more than 2 characters. So as you can see here, I will not classify as a word, a will not classify as a word, is will not classify as a word. So what will be left with will be stuff like love this car as positive, this view amazing as positive, excited about the concert as positive, and so on. And now we have another list, test underscore tweets, and this will be used for testing the whole thing. So let's come a little bit down. So our first job is to get the words in our tweets. So what we're going to do is we're first going to make sure that we break down our tweets into individual words, so as to understand that what kind of sentiment is attached with each of these words. So what we end up with is this, that we have love will be attached to positive, this will be attached to positive, car will be attached to positive, amazing will be attached to positive, and so on. So get underscore word underscore in underscore tweets, this function will be able to get out all these individual words in the tweets that have been used, and associate them with the sentiment attached to them. And then we're going to write another function, get underscore word underscore features, which takes out the frequency distribution for all these words. That is, we're trying to understand that how many times have these words been repeated. Now we're doing this so as to make sure understand that what kind of weight do they give to the sentence. So if a certain word has a positive sentiment attached to it and it is repeated in a sentence for like 3 times, so obviously that sentence will become all the more positive, even though it might be negative overall. But again, we're using frequency distribution to understand that. How will that work? So here we can see word underscore features will get the, first of all we'll have the words in the tweets, and on that we'll be performing the frequency distribution, and that will be stored in word underscore features. And after that we'll be able to extract the features out of each of these words in the word underscore features list. Just hold on. Yeah. Okay. So now we have attached. Now we extract all the features out of these words. Now it's time to train the set. So we have training set and training underscore set here. As you can see, NLTK.classify.apply_features, extract_features, and tweets. So the tweets that we have initially had been put together over here in the tweets list. So we're going to use them as training set, and that is going to, and the training that is applied on them will be stored in this variable training underscore set. And based on that, we're going to run the naive based classifier to train itself on the training set that has been generated, after which our classifier will be ready. So by this statement, our classifier is ready now. So let's test on it. We have a tweet, I love my friend. So we're going to run this program and see exactly what does it classify this tweet as. So we have, you can see here, I love my friend is attached to a positive sentiment. So that means the classifier is able to recognize that, okay, fine, I love my friend means that there is a positive sentiment attached to the sentence. So now we are going to try a different sentence. So something like, I'm typing with hand, so let's run this. And as you can see, I don't like you has a negative remark attached to this. So obviously we have only 6 to 8 tweets as training set over here. So our application of this program is very limited. But as you can see that even with limited training, it has been able to recognize two vastly different sentences as positive and negative remarks. Now, as the training set becomes larger, we'll be able to ensure that the program is a lot more accurate in trying to ensure that the sentence is a positive remark or negative remark. But that is all based on the size of the training set. The greater the size of the training set, the better will be the performance of the program. Now this is just for example over here. That's why we are using a small training set that contains 9 tweets apparently. And this is how this works. We'll also be talking about